Good morning, everyone. We are Konoha Genin, and today we are excited to present our project on a significant challenge in the telecom industry, which is customer churn. What is customer churn? In today's highly competitive market, a company's long term success hinges on its ability to retain its customer base. Customer attrition or churn poses a significant threat, as the cost of acquiring new customers is far greater than retaining existing ones. An unmanaged churn rate can lead to volatile revenue streams, inaccurate financial forecasting, and continuous drain on resources, threatening company stability and reputation. So, why this project matters? This project is motivated by both a pressing economic imperative to mitigate financial losses and the strategic necessity of a customer first approach. Persistent churn highlights systematic gaps in business strategies, underscoring the urgent need for a more proactive approach. By pinpointing vulnerable customers early, this research aims to empower business to develop proactive retention campaigns, thereby improving customers' loyalty and securing long term revenue. So, the main objective of our project are predictive model development, root cause and risk factor analysis, strategic recommendations. So, we were working on telecom customer dataset containing 7043 customer records, 21 distinct attributes. So, these are our attributes. Customer ID. This is a unique identifier for each customer. Gender. This tells us whether a customer is male or female. Senior citizen. This is a binary attribute 1 for a senior, 0 for not. Partner or dependent. These S or no field tells us about the customer's household structure. Tenure. This is a critical feature representing the number of months the customer has been with the company. Phone services, multiple lines, internet services, online security. These are other attributes which we were using. So finally, we have a set of add-on services that provide a deeper view of customer engagement, which are online security, online backup, device protection, and tech support. These are crucial support-related services. And streaming TV and streaming movies. These entertainment services tells us how much the customer uses the platform for their lifestyle needs. Now I'll hand it over to my colleague who will walk you through how we clean this data and the initial insights we uncovered through visualization.
Good morning. So here we are reading the file called customer churns, where we have all the information about customer, his gender, customer ID, citizenship, partner, dependent, all his information, which network he is using, and what all we can see here. And next, here we are seeing the information about the customer using the commands, and here we are checking for null values in the customer table. What all values of the table are null? We don't have any null values in this table, and we are trying to remove customer ID column by using drop command. And here we are changing the cell which have other numerical data to NA. And here we are filling mean into total charges NA cells, calculating the mean. We are using code for this correct, verifying that the null values are gone, and we are removing rows which are tenure as 0, and here here we are seeing the visual. We are trying to visually tell the stories, focusing on turning clean data into meaningful insights through visualization. It begins with a section header that marks the shift from data cleansing to insight generating. Next, libraries such as matplot and plotly are imported, and warnings are suppressed to create a smooth, unclustered visualization experience. Plotly is used for interactive visualization, while matplot handles static plots. A pie chart illustrates customer churns by gender, giving a quick overview of churn's distribution across male and female customers. Through it often shows minimal differences, separate gender distribution analysis on non-churns and churns provided count, and helps in comparing retention and churn patterns across the genders. And a histogram of churns versus contract type highlights strong signals. Customers with month to month contracts typically show higher churn, pointing to a clean opportunity for retention strategies. Then a pie chart of payment methods show the distribution of how customers pay, followed by a histogram of churns by payment method, which often reveals higher churn rates among electronic check users, indicating they could be encouraged to switch to more stable payment methods like autopay. Next, the internet service distribution is analyzed separately for males and females to see how churns varies by service type and gender. This leads to a group bar chart combining gender churns and internet services more frequently regardless of gender. The analysis continues with churn distribution based on dependency, pattern status, and senior citizens. Typically, customers with no dependency or partners have higher churns, while senior citizens may show evaluated churn rating despite forming a smaller segment. Future histograms Further histograms examine churns in relation to online security, paperless billings, tech support, and phone services. Customers lacking online security or tech support often show higher churns, while paperless billing and phone services provide insight into behavior influenced by servicing features or demographic factors. Before modeling, the unique churn values are printed to confirm label consistency, example yes or no. Using Seaborn, monthly charges distribution for churns and non-churns are plotted, often showing that customers paying higher monthly charges are more likely to churn. A heat map of total charges by churn occurrence among low value or high value customers. Finally, a box plot of tensor versus churn visualization, tenure versus churn visualization, and how it impacts churns clearly indicates that customers with short tenures are more to leaving, emphasizing the importance of earlier retention efforts. Overall, the phase transformation, raw data into visualization, narratives that pinpoint churn, division, customer pattern, and actionable areas for improving retentions. And we can see we have different type of visualization for all possible churns, distribution, phone services, and etc. etc.
So hello everyone. Now let's quickly go through advanced techniques we used in our analysis like data transformation, dimensionality reduction, and association rule mining. So the first one is data transformation. So in this step we use a process called label encoding. We created a set of rules to convert every text category into a specific number. For instance, yes became 1 and no became 0. As you can see from the code and the resulting table, this transformed our entire data set into a purely numerical format, making it ready for our model. And next we have dimensionality reduction. So in this we have explored dimensionality reduction using a technique called principal component analysis or PCA. So the goal here is to reduce the number of features in our data set without losing important information, so that it helps our model simpler and more efficient. And we first scaled our data to ensure all features were treated equally, and then PCA identified the underlying patterns or principal components, and the plot shows us The plot shows us the results. The key takeaway in is the red line. It shows that we can capture 95% of the dataset's information using just 10 principal components. This means we could potentially simplify our model by focusing on these 10 components instead of all the original features. And next, we have the association rule mining. So think of this like a supermarket analyzing shopping carts to see that customers who buy bread also tend to buy milk. We did the same thing with our telecom services to find which ones are frequently bought together. So that in this we have used the appropriate algorithm for this. First we organized each customer services into a basket. Then the algorithm identified combinations of services that appear together more often by random chance. We filtered these to find only the strongest and most meaningful rules. For example, discovering that customers with online security are also very likely to subscribe the online backup. So that these insights are incredibly valuable for creating targeted marketing bundles and promotions. That includes our overview of the advanced analysis, and these steps were crucial for building a robust and insightful predictive model. And you can see the frequent item sets and association rules in the table. So as my friend discussed, the initial steps involve loading and cleaning the data, and the really important work starts from here, which is feature scaling and splitting. So first we have to separate our data into two parts: X, which contains all our predictive features like tenure and contract type, and Y, which is our target variable like churn. We explicitly convert yes to 1 and no to 0. And next, we use train test split to divide our data into a training set 80% and a testing set of 20%. This is a critical step in machine learning to prevent data leakage. So the model will only learn from the training data and will use the unseen test data to get an honest evaluation of its performance. And we have choose our model as logistic regression. We selected this model because it is not only accurate but also highly interpretable, which is a perfect for a business context where we need to understand why a prediction is being made. And the line model fit X train scaled and Y train is where the magic happens. The model learns the complex relationship between the customer features and the churn outcome by analyzing the patterns in our scaled training data. And at last, using the Python's pickle library, we save our trained model and fitted scalar to files named model.pkl and scalar.pkl. This is a crucial step for deployment. It allows our web application to simply load these saved files and start making predictions immediately without having to go through the entire training process every time someone uses the dashboard. By running this single script, we have created a repeatable and reliable process to build the predictive engine that powers our entire project.
So this is our project file. It consists of app.py, customer churn CSV, that Excel file which consists data, and the Jupyter file to represent all the pre-processing and visualizations. And we are having two another PKL files and one train model like Python file which has the code, and app file which is integrated to Streamlit to show the dashboard. So first of all, what's our project? To run the project, first of all we need to train the model. So for this we need to run the file, train model file. Then we need to run the main file. So this is the dashboard. We'll come to the dashboard afterwards. So first of all, here architectural bootstrapping is going on. We begin by setting the operational parameters for the Streamlit environment. The application initializes the page settings such as layout, iconography, and sidebar state. ensuring a consistent user experience aligned with the corporate branding. We will load the two backend assets, which are model.pkl and scalar.pkl. Model.pkl is trained ML classifier, and scalar.pkl is normalization scalar for numerical standardization. And next, coming to like intelligence layer. So the engine leverages a pre-trained machine learning model. The model predicts the likelihood of a customer churning based on historical patterns. Feature importance values like contract type, tenure, and service usage dictate the model's decision weightings. Next, it's all about UI UX like CSS, how the Streamlit designs the dashboard of the glue effects and side-in transitions, cards, buttons, and data panels. Next, coming to data ingestions and pre-processing. So the left sidebar acts as a customer profile intake form. Analysts or CRM managers can feed in individual customer attributes such as tenure, service plan, customer details, the how many partners, how many multiple lines is he's or she is using, phone service, paperless billing, and internet service, backup, and whether it's a senior citizen or a normal citizen, and contract and monthly charges. Everything will be showed in the sidebar. And we are having like on the helper function get churn reasons, which identifies the top churn drivers like short tenure, month to month contract, high charges, or lack of technical support. Then we are having generate retention offers, which tailors the personalized offers, discounts for annual plans, premium support, complimentary streaming services, converts the churn risk into actionable retention strategy. Next, we are having generate proactive offers for stable customers, produces loyalty incentives such as complimentary speed boost, anniversary credits, referral rewards, reinforces brand loyalty and customer lifetime value. And next, we are just using the visualization and insight delivery. So first of all, if we enter the customer details in this dashboard, and we'll select the tenure, and we'll select the contract as like there will be options month to month, 1 year or 2 year. Now we will be selecting as 1 year. And payment method, electronic check or mail check, or like all the types of the payment methods, and the total charges. Then if we predict the churn risk, it will show the prediction customer will stay like confidence 77.65. This is the algorithm which follows the customer input. If we choose another customer input, like we'll choose senior citizen as 1, that means he's a senior citizen, he or she is a senior citizen. And we'll reduce the tenure, and we'll also keep the multiple lines are yes, and partner no, dependents no. Then we'll ask our website to predict the churn risk, and it also shows the customer will stay, but the confidence reduces. And it also gives suggestions to increase the churn rate, like such as offer a referral bonus, $50 credit for each friend they refer who signs up for service, so that the people who uses this telecom service can stay for a longer period. We'll change the customer input. So for this customer input, it's showing that high risk of churn. That means he or she may leave this telecom industry. So for that, like what are the reasons the person can leave or can lose this contract? So we'll also offer recommendations such as offer a free speed upgrade for the next 3 months to showcase the full potential of a service. In that way, we'll offer some recommendations, and these are the reasons why the person is leaving. So this is our project. Thank you.